Good day, ladies and gentlemen. This is Sarel van Grinnen, aka Mr. VG, and I'm back with the second video on distance formula. In this specific video, we are going to look at the applications of distance formula in a variety of situations. So let's look at this example. I'm giving you three sets of coordinates, A, B, and C. The first question is, calculate the lengths of AC and AB. Now for you watching this video, this should be easy because you would have done it in the previous videos as well. Let's go directly into the formula. So this formula, I love it and it's easy. Let's substitute in. The distance between A and C is simply the root of 81 plus 49 or the root of 130. Please do not worry about putting that step in. Straight off, go to the root of 130. Next up, you are going to do the distance between A and B. Exactly the same formula, same procedure, giving me an answer of 5. Once I've got this, I love to put it in on my sketch. A very, very important thing is don't ever think that once you've done something in analytical that you're not going to use it again. So if you go and you put it in on your sketch, you now go over to the second question. The second question is determine the perimeter of triangle ABC. So whenever an examiner asks me this, the first thing I write out is what are they looking for? They're looking for perimeter. So I go to a formula. The formula for perimeter is simply the distance between the sides or the length of the sides added together. Now I already have AB and AC, but I don't have BC, so I'm going to go and get the distance between B and C. I've gotten the distance there for you as being the root of 153. So in other words, the perimeter is simply adding those values together. I put it in my calculator and I get 200 or 28.77 units. Am I going to lose marks for not saying units? No, you won't lose marks necessarily, but I would just write it in just to be 100% correct. But let's now look at question 3. Remember, I have now those 3 things, or 4 things actually I have at this moment. I've got the length between A and C, or the distance between A and C. I've got the length of the line segment AB, and I've got the length of the line segment BC. So let's try and see what strategies are there for proving that there's a 90 degrees. The first strategy is that the gradient between A and C times by the gradient between A and B, or the gradient of line segment AB, must be -1. That's the easy way. But because this is a distance formula video, I'm rather going to look at the converse of the theorem of Pythagoras. In other words, if BC squared is equal to AB squared plus AC squared, then angle A must be 90 degrees. So I'm going to start by looking at BC squared, and that's simply 153. Then I'm going to look at AC squared plus AB squared. Calculating those values, I get 155. Are they equal? No, they're not. So in other words, BC squared is not equal to AB squared plus AC squared, and therefore angle A is not a 90 degrees. So this is a video about the application of distance formulas. Now the application of distance formula doesn't stop here. We can also go towards parallelograms, rectangles, different types of triangles, squares. There's so many of them, but I'm giving you a bit of a taste. In some of the videos coming up later in the exam practice, we'll look at other applications of the distance formula. So please tune in to our next video where we're going to go over to midpoint and the application and practice thereof. So have a beautiful and wonderful evening. This is Mr. VG signing out. Cheers.